Imagine waking up tomorrow and the only water you have to drink looks like this. For millions around the world, this isn't imagination. It's daily life. So, for our Engineering 1300 final project, we created a hands-on exhibit that doesn't just tell the story, it lets students experience the challenge of obtaining clean water. Welcome to Project HydroSafe. Our project fits into the semester theme of Engineering Solutions for Global Challenges. We built a complete water filtration exhibit, powered by Arduino, that teaches middle and high school students how water is cleaned, and why access to clean water is still a major issue around the world.
In 2021 alone, over 800,000 people died from contaminated water. Our objective was to build an ADA-compliant, interactive, and educational demonstration that shows what people in underdeveloped regions often have to do just to get drinkable water, as well as how different filtration methods work. Our exhibit needed to stay within a size constraint, be safe for all ages, and engage multiple students at once. The target users are students ages 5 to 18. Performance-wise, our system needed to simulate 3 filtration stages, use less than 120 volts, provide visual feedback, and stay within a budget of $150. Our final build successfully clocks in at $119, meets electrical safety limits, and measures as 3 feet long by 1¼ feet wide by 3 feet tall.
Project HydroSafe is more than a filter. It's an experience. Students scoop dirty water, choose a filtration method, watch the change in real time, and learn the science behind each step. Instead of simply watching water get cleaned, students actively engage with each method and think critically about why some filters aren't enough. We compared several designs and ultimately choose this system because it balanced educational value with interactivity while staying accessible and budget friendly. Each filter represents a real method used around the world.
Here's how the system works. The exhibit starts with the students scooping water from our dirty water bin.
It's disgusting.
Mixed with coffee grounds, pepper, oil, dirt, leaves, and twigs to mimic real-world contamination. Then they choose one of 3 filtration bottles, each representing a method commonly used in different communities around the world. Bottle 1 is our most advanced filter. It includes gravel, which catches large debris. It also has sand that traps smaller particles, as well as activated charcoal, which absorbs chemicals, odors, and oils. This combination represents one of the most widely used filtration systems globally. Bottle 2 doesn't filter solids, it disinfects. Students press the button to switch between a purple and orange light. The purple light represents UV disinfection, which in real systems kills bacteria using ultraviolet radiation. In our exhibit, the light is only a simulation to keep students completely safe. The orange light represents boiling, one of the oldest purification methods. These 2 options teach students that filtration alone isn't enough. You also have to kill pathogens that you can't see. Lastly, Bottle 3 uses a simple piece of shirt to represent cloth filtration, which is still a common method in underdeveloped regions. It removes large particles but not bacteria, helping students understand why water can look cleaner but still be unsafe. After water passes through whichever bottle they choose, it travels down our slanted rain gutter and into the clear water jug. This lets students visually compare dirty water in versus cleaner water out. Once the jug fills to a certain level, the faucet releases the water back into the dirty water bin, creating a continuous purification cycle that the students can repeat indefinitely.
To build this system, we first went to Home Depot for lumber, a thin plank, 16-inch gutters, and nails. Dollar General provided us with bottles and socks. Walmart supplied the water jug and the ingredients for dirty water, and we collected natural debris such as dirt, leaves, and twigs outside. PetSmart provided the sand, gravel, and charcoal. We cut and carved holes for the bottles, built the frame out of 2x4s, and mounted the gutter and water jug at a precise tilt with the help of wood and a crunch box. The Arduino was safely hidden inside the lower compartment to avoid water damage. Lots of duct tape later, our project was ready for testing. Testing was the fun part. Messy, but fun. This involved running dozens of pours through each filtration stage and observing clarity changes. We confirmed that each method produced the expected filtration effect, and the gutter system reliably cycled water back into the dirty bin with minimal to no spills.
Cross your fingers.
Wait.
Yo! Oh my god.
It's coming out perfectly clean. We also tested our automation, which was a huge failure. Originally, we designed a 3D printed servo lever to automatically open and close the water jug faucet when a button was pushed. Unfortunately, the servo wasn't strong enough to push or pull the faucet. This was likely because of our use of cheap materials while trying to stay under budget. This was our biggest disappointment, but also our biggest learning moment. Instead of forcing a flawed idea, we pivoted. With input from Professor Dickenson, we replaced the servo mechanism with a tricolor LED system that toggles between purple and orange to symbolize UV disinfection and boiling by the press of a button. This turned out to be safer, simpler, and more reliable.
We learned that engineering is all about adapting. Ideas rarely work the first time. We gained hands-on skills in prototyping, filtration science, Arduino programming, and problem solving. In the future, we redesigned the faucet mechanism using a stronger gear motor and base, as well as incorporating a water purity test to measure how the filtration affects contaminant levels.
In the end, Project HydroSafe demonstrates how real filtration works and why clean water access remains a global challenge. Engineering isn't just about solving problems, it's about inspiring others to solve them too. Our hope is that this exhibit not only teaches students, but inspires them to think like engineers. Thanks for watching, and we hope Project HydroSafe helps spark the next generation of innovators.